project. Thermal actuator device is assigned for my group of MEMS 15 where we choose SU8 thermal actuator for this design project. The operation of thermal actuator depends on the coefficient of thermal expansion of its material. For my design, static structural is used as the analysis system. The SU8 material as the base layer and copper material as the surface layer is shown in the animation video. Then the dimension of the design is shown in the table. When the input of different pressure value is applied, the structure of the device will bend down and the output of the total deformation is observed and recorded. The higher the pressure value, the higher the total deformation value. The maximum pressure value that can be applied is only at 30 megapascal. In conclusion, pressure is not the best input and not suitable especially to apply high pressure when using SU8 material for operating of the thermal actuator device.
Hi, Assalamualaikum. My name is Quratun Ayuni and I will explain detail about my MEMS thermal actuator design. So, the type of MEMS analysis system that used is static structural. Next, the material that used is titanium and gold. In this design, the SU8 is replaced with titanium as base thermal actuator. So, the input of the design is the pressure. In this simulation, the different value of pressure will apply from 0 to 300 megapascal. Then, the output coefficient when apply pressure on free end device, the free end device will be bent down. Next, for working principle. Firstly, the material used for thermal actuator is titanium and metal resistor used is gold. Secondly, the input is pressure and the output is total deformation. And lastly, when apply input on the thermal actuator, the free end actuator will bend down. Next, for the discussion, this is the dimension for titanium and the value of coefficient of thermal expansion. Next, in conclusion, the result for titanium material show that the pressure increase and the total deformation also increase.
Hi, my name is Noor Asuha binti Zainon. As we know, the efficiency of thermal actuator depends on the coefficient of thermal expansion of its materials. For my design, the materials that I use such as copper as the base layer and silver as the surface layer. Then, I use the temperature as input and the total deformation as output for this parameter. The steady state thermal analysis is as input simulation and static structure analysis as output simulation are used for the voltage displacement parameter analysis. Moreover, the dimension of the design as shown in table. In conclusion, any material that is copper and silver can be used for the thermal actuator subtract. So, the deformation is less compared to the model bounding bond is not suitable for this model. The simulation result has been represented as shown in the animation. The output simulation suggests that with a maximum of 1698.4 meter total deformation, the actuator was bending up.
In this project, the SU8 thermal actuator device will be used in application that related to COVID-19, which is micromanipulator application. This is because the micromanipulator is developed from this miniature device which can be used to precisely hold and assemble microparts such as microgear and micromirror.
Further, this SU8 thermal actuator will apply in micromanipulator arm for microscope equipment that will be used in medical application. The micromanipulator arm will be integrated with SU8 actuator in order to produce control mechanical motion.
From that, the microscope can be used by technologists or researchers to make research about COVID-19, either to analyze, monitor and investigate about the detailed image of the virus.